Sebentar ya teman-teman, mungkin ada kendala.
Baik, Pak.
Can you hear me now?
Ya.
Oh,
Terdengar.
okay. That's a
Okay.
relief.
Ya.
I don't know what happened actually. I tried to share my, because I'm using my laptop and the screen is very small and I wanted to have a bigger screen. So can you?
Okay, no worries.
Yeah, how about now?
Yeah, very clear.
Oh,
No
okay.
worries.
Yeah. That's
So
really relief.
please feel free. You can use English.
Okay, thank you so much.
Or maybe in Japanese.
Okay. I'm sorry
Feel
for
free to
this
use
trouble
language.
actually. I didn't expect it that I have problem.
Okay.
It is,
No worries.
okay.
Okay, please silakan bisa dimulai, Mbak Dede, mungkin bisa share.
Hai. Tunggu saya masih.
Iya Pak, bentar dulu.
Yeah. Can you see the screen now?
Yes.
Okay. So good morning, everyone. So today agenda is remote sensing, right, for the 3-in program. Thank you, Abu Sensei, who invited me, and then this is a really good chance for me. And I hope this is not really early morning for you there in Malang. I think it's 7:30, and in Tokyo we 2 hours ahead from Malang, so it's quite a good time for me here. Perfect time. I already awake. So if you feel sleepy, please feel free to grab your coffee or tea, and then please don't sleep during my class. It's not a lullaby. Yeah, I don't know how to make a good voice to make you awake, but I will try my best. Okay, so today I will introduce the remote sensing, the general concept of remote sensing, and then the second meeting I will share the application of remote sensing. So probably you have image how to develop a research with remote sensing with your field. Okay, so before that, I would like to introduce myself. Okay, so this is my profile. Forgive my selfie. I try my best to give you a good image, but it's not really good actually. My name is Andi Baserimba. Yes, I'm originally from Sulawesi Island. I'm a business. And then currently I'm an assistant professor at Sibaura Institute of Technology, and then a visiting lecturer and researcher at United Nations University, Tokyo. I graduated from Gadjah Mada University in a field cartography and remote sensing. And then I continue my master at Udayana University, and I got a chance to have a double degree, and then continue 1 year in Yamaguchi University, Japan, and then finally I got 2 degrees. So probably it's like in Brawijaya as well, they have a sandwich program with others university in abroad in Japan or in other country. And then after that, I've graduated from the both university. I continue to my PhD and the same laboratory with Abu Sensei. same university with Pak Abu, and then same laboratory, same professor, and then mostly similar major. I mean, it's a topic of research. So I was developing flat model, and then Abu Sensei develop tsunami models. But the tools we develop, how to develop the research is quite similar. Yeah, now I already say that my current positions, but before that I was a postdoctoral fellow at the University of Tokyo, and then in United Nations University. And prior to that, I was a junior researcher at Udayana University, Bali. And then after graduated from, we talk very back. After graduated from Gajah Mada University, I moved to Bali and become a research assistant to a consultant, and also to the NGO, international NGO in Bali. Yeah, so that's my career step. Yeah, I start from it's not like usual people like start from with a company, but I start with research. Yeah, that's everyone have their own step, and then own way. So I believe that your guys will have a bright future. Yeah. So my research interest is remote sensing and GIS. So mostly my research using GIS and remote sensing. And then now I develop research using climate modeling, and try to learn computer language. I use Python. Maybe some of you also using Python in developing research. And yeah, so last time also I have research about the flood. The coastal management when I was in Udayana University, and then I have several research about the flood modeling and natural disaster and mitigation. So you can contact me through this year, my personal email. Actually, I will share my my institution email, but I forgot the domain because it was too many dash. And so I will send next time. I will share my email. So this week we will talk about the remote sensing itself, the history of remote sensing, the remote sensing process components, spectrum, resolution. So only the basic one that we have to know in terms of remote sensing. And the next week, as I said before, that we will talk about the remote sensing application. So I believe you are now already have image how to develop your research. So probably this will give you hint, like idea to how to make research in remote sensing. Okay. Okay, now we continue. We start with the term of remote sensing. So when we talk about remote sensing, this is an art because we use image. We got information from the image. So probably you always playing with the camera, and then that's a kind of art. It's not only drawing, and it's not only that singing. People's working in television, or they are artists. So this is also kind of art, and we combine science. So because we extract the information from our Earth or our space, and then we make a research about that. So that's combined art and science obtaining information, but without physical contact. So it's like a magic. Yes, like now that maybe physical contact is not really important now because we have a developing technology, and that's we can communicate like this now. We separate the ocean, we difference the islands, but we can sit together. That's using technology. So without physical attendance, we can do. So this is the same. Without physical contact, we can get the information. So it's like not previously when we want to know the information, we go directly and then get the information, but now we don't need to do that. So we can get information without any without go anywhere. So just sit down in front of your computer and you can process the data. So another definition is the let's wait a minute. I want to use the lesser point. Yeah. So next is the process of collecting information about Earth surface and phenomena using sensor, not in physical contact, like I said before, with the surface and phenomena of interest. So we cannot collect all the information that we see. We just extract one or two information. That we want to extract only ocean color, or we cannot combine with the land because this is because we use sensors that only specific in one object. In remote sensing, there is a medium transmission in force like Earth's atmosphere. Okay, so we talk about the sensor. We have a sensor in our body. Yes, like we have eye, we have skin, we have ear, nose, mouth. That's a kind of sensor. And then in remote sensing also we have sensor. But in we know that camera, all of us have a camera. That's kind of sensor. So maybe your phone, so many camera attached there. So maybe 5 or 10 camera. No, I'm just kidding. So maybe it's like the currents, they use 3 camera, not your phone. That's a kind of sensor. And it's like binocular. So that's kind of sensor. Okay, so let's continue the history of remote sensing. So it's not, not all field. This is a very new field that not like mathematics, not like physics, but we develop from that. It's not like economic. Yeah, that's a very old field, but we are just to start around with balloon photography. That just starts in 1858, so it's quite new comparing to others. And then in 1903, a pigeon camera. You can see the picture, like the cute pigeons bring the camera and then they fly randomly, and that's very influenced with the, with the wind, and but you can see the pictures is like a white area. That's very wide angle camera. So but that's the beginning of remote sensing. And then so finally in an 18th around 80 years later, sorry, this mistake. My mistake is actually 19. And then 90 years later, people develop kite photography, and then so people can direct the direction, so which part they want to record, not like randomly using pigeon. And then so during the World War I and II, the advantage of remote sensing developed so much because they use for the army and for defense and for the strategy of country. So how to like know the rival place of to the strategy of war. And then currently just around 733 how just around after independence of Indonesia, that's people develop space of remote sensing. So that's kind of new. It's not 100 years back. I mean, for the space remote sensing, it's just a very new, and it has been developing and will continue developing. Okay, so in remote sensing, there's I mean, this is a very basic of group of remote sensing. So there is a people that make a mission of remote sensing and choose this of sensor. It's like mission plan. That's like a government. This is a government decision, and that's it's like Indonesia want to have a remote. I mean satellite. So they have to like a mission. What the mission they want to do? It's like what and then they have to choose what the sensor that want to choose. Like they want to observe the weather, of course, different sensor. They want to observe the water, different sensor, and observe the land, of course, different sensor. So the decision maker have to make and also the scientists have to make a decision what the mission plan and then what the sensor they want to do. I mean to choose, and then after that, it's like the second group is reception, recording and processing that of the signal. So this is part of mission plan can be decision makers like government, and also like in Indonesia like Lapan, or in NASA, in Japan, in America like NASA, and in Japan it's like JAXA. That's make a decision plan and choose the sensor together with the government. And then for the second is reception, recording, processing is totally like NASA job, Lapan and JAXA. It's not our field there. That's really like a sensor can record from the satellite and then recording, and then the process to send to the earth, and then people will process the signal, and then after that they will send us the result. So the result that we see like Google Earth, Google Map, that's a kind of the result that from the remote sensing. So that's our part. That's our part. And after that, we can make another many kinds of analysis. Okay, are you still awake? Yeah, hopefully. Yeah. And then we talk about the orbit. So there are two. You have to remember there's two orbits. So one orbit is only like stay in one position. It's like they move at the same speed, the same place every day. So just like always monitoring Indonesia. So they don't move. They just stay and following the Earth. So every time we get the same image. So yeah, Indonesia have this geostationary orbit. Lapan has. And then another is sun synchronized orbit. So this is a worldwide covering data. So they cover all area in this on the Earth. So we can get information all country, and then their speed is not depending on the Earth speed. So they have their own speed. So that's synchronized or a sun synchronized orbit and geostationary orbit. So you have to make like a clear decision here. So if you want to have like in only Indonesia data day by day, you can use geostationary orbit. And if you want to use global data, you use sun synchronized orbit. So this is similar. So this is the vantage point. So there is so many kind of remote sensing. Yeah, that's observation tools. That's ground observation tools like terrestrials. That in the previous time, people that observe the Earth, they're using vessel, they're using ship, and then the ship is a move, and then we got the information. So that the previous times to get the information, and then we just like a ground-based receiver, and then then so many type, and then people develop airborne, and then maybe you play drones. So that's a kind of airborne observation tools. And then there's a near space, so like ALOS, near space like Landsat, they are still near space. And then for observe the others places, this very high space like Earth space out from the space. So they have another satellite. This is as I said before, that's the platform of remote sensing. It's like a ground-based. They have a ground-based. Just like when we monitor the the climate, local climate, we use the local ground-based. So seems like that. And then the airplane and drone-based. So maybe some of you play drone and have a drone. But in Indonesia, it's okay to have a drone. And it's not really so many regulation on it. Just if you have money, you can buy with the low, middle, or very high quality. But in Japan, we cannot play. We cannot fly the drone easily because so many regulations. So like in Tokyo, if my friends want to have like good video, so they have to go outside from Tokyo to record. It's like a very nice video from the space. But in Indonesia, maybe you can do it easily. And then satellite based, as I said before. So this is we talk about the electromagnetic spectrum. So please remember the way how to get the information. There is 3 types. So it's a passive sensor, and then another is a passive sensor, but using So there is 2 passive sensor and 1 active sensor. So what is passive sensor? So it's like someone give you money, but you don't work. So it's kind of like passive. So you have money source from others, and then you just receive. So you are passive, like a passive, receive money only passive. Yes, it seems like in remote sensing. So for example, here's the Earth surface. So here the Earth surface, and I'm sorry. Can you see my pointer?
Yes.
Okay, that's good. Yeah, I thought I just make a point, but yeah, that's really lifting. Thank you so much. So like the suns have energy and then send to the earth, and then the sensor receive the reflected sunlight from the sun, from the earth. So the sun send the light to the earth, and then earth just reflect it. So that's kind of passive sensor. Yeah, you understand from here, eh? So this is a passive sensor. And then another passive sensor is like sun send energy to the earth, but earth keep the energy and then release after the suns go, or I mean at night, so they still keep the energy and then release later. So it's like sun absorb earth absorb the heat, the temperature, and keep on the soil. Yeah, keep on the temperature, and then during nighttime the heat will be released, and then sensor will record how many energy released from the sun, I mean from the earth. So that's a kind of passive sensor also. So there is two passive sensor. So when when the just reflected sunlight, so that's a passive sensor one. And then when only just release energy, but the actually they just keep, actually they keep first and then release, and then sensor will record. So that's a kind of a second of a passive sensor. Okay, so halfway to go. Yeah. Now I already start 30 minutes, I think. Okay, I continue. For the active energy, active sensor. So like we have we work and then we get money. So that's active. We got money because we active. So it sounds like this. They send, the sensor send energy to the earth. Then earth reflect back. So that's we call active energy, because the energy, I'm sorry, my slip out time. I mean, that's active sensor. So the energy from sensor sent to the earth, and earth send back the energy, and then the sensor receive that the information. Yeah. So that's a kind of electromagnetic spectrum. Okay, so I will continue here. The electromagnetic radiation. So remote sensing. Okay. I'm sorry. Actually, I make a block here, but I think okay. In remote sensing, we only work in this block. So we play with ultraviolet light, visible, infrared light, and microwave radars. So now our eyes can see the color, because we are working here. Our eyes working in the visible wave. So like X ray, gamma rays work like for the medical thing, and then TV, radio, and any like a long wave, that's on communication, so like radio, TV, and others. So it's like we are actually working in if see this is short wave, so it's like a gamma and X-ray, and also very long wave, and then actually we just like playing in the middle one. Okay, so this is I always say to the student when I give the class, this is very important graph. When I was students, my so like my lecturer always my teacher always like push us to remember the these windows when when we want to like make analysis using a remote sensing. So this is really important. So for example, why this is important? Because from this chart we can decide what wavelengths we want to use. So for example, we want to analyze water. For example, water, the maximum is just around, this is 1, this is 5. So here in the middle, not around. I hope, yeah, if I don't mistake. Yeah, see, so just around 1. So if we want to observe waters and then we use the wavelength is 1 micrometers, it means we got nothing. We got nothing because the graph is only until here. So we don't have any information here. We cannot get information from this wavelength. Do you understand? Yeah, so like we use the Landsat, and then so we see the band of Landsat, and then so we choose the band after, yeah, it's a more than 1. It's a more than 1. So it means nothing because the graph is only until here. And that's when we, for example, we want to analyze soil, and then we use around the atmospheric absorption. Sorry. So this is we have to avoid this one, this wavelength. We have to avoid this wavelength because why? This is so many biased information because the atmosphere. So this is a really important. Yeah. So like here when we want to, another graph actually that we can see here, like average scrub and grass soil. So we can see from here, and then this is really important graph because that this graph help us how to decide the wavelengths that we want to use, because we just talk about the wavelength. Yeah. In remote sensing, it's not a color. Color, we just decide the color, but we talk about the wavelength. Okay, in remote sensing, we continue. In remote sensing, there's several components. So yeah, the energy. Yeah, if we use passive sensor, the energy is like a sun, and then there is a B here is irradiation and atmospheric. This is a kind of noise here. B is a noise, the object that we want to observe, and D is the satellite. And then after the satellite, we send to the Earth, and then we can process it, process the data. Reading the signal, saving, recording, and so on, and that's we can using for the application. So this is the step in remote sensing, the flow of in remote sensing component. The fundamental term in remote sensing, this is a really, another important, very important in remote sensing. There is 4 types of resolution. So spatial, spectrum, temporal, and radiometric. Yeah, I will tell you what is that. So maybe you already know actually, because it's not really difficult term. It's like spatial resolution. The Earth's surface are covered by a pixel of an image It's known as spatial resolution. So maybe like once box, if you zoom in, yeah, if you zoom in the image and then you